Today's lesson is on checking solutions. So once we solve an equation, we need to check the solution to see if we didn't make any mistakes. And this is a very, very important part to making sure that your answers are correct. Okay, so we're starting with a mystery problem, kind of like what we were doing in chapter 1. And our mystery problem says, if I add 2 to a number, then I triple it, I get 9. So making this into an algebraic equation takes a little bit of investigation, so we can use the cubes method and just circle the numbers. Well, I got a 2 here, I got a 9 here, and then our math action words would be add and triple. Okay, and we need to also pay attention to the order of which things happen. So if we're thinking about, well, what does this look like? So I'm thinking of a number, and I add 2 to the number, we should know that it basically looks like this. The number would be x, and then I'm adding 2 to it, right? So that's the first action. Add 2 to a number. Then I triple it. So that means this comes first. So I'm going to put it in parentheses and then triple it. So that means times 3. Now what that looks like is basically just I have this and this. So I triple it. Okay, so we don't really need that 3 anymore. So let's take that 3 out. Okay, so I have a number, add 2 to it, and triple it. Now, I get means equals. Here's the 9. So we can kind of envision this. If it was an algebraic equation, remember how I put the parentheses here and the 3 there? So I first have a number. I add 2 to that number. Then, after I do this, first, parentheses, I'm going to triple it. I get 9. So here's my algebraic equation. All right? Now, if you look at the tiles, you know that this expression right here gives us 3 x's and 9 1's. Right? So we call this using the distributive property. 3 times this and 3 times that. I got 3 x's and 3 2's. That gives me 3 times x is 3x. 3 times 2 is a positive 6, which is equal to 9. Now, we've learned our legal moves previously using the tiles, and we know that we share this and we share this. 6 1's on both sides, so those can be removed without upsetting the balance. So now, here's what it looks like in an algebraic equation. I'm minusing 6 on both sides. That is balanced still. Okay, so I'm balancing that equation, keeping the balance. So that gives me 3x. This is a 0 pair, so this just kind of zeroes out, is equal to 3. And then our final step can be, you see, well, I want 3 of them, so one move I can do is I can just kind of cut this into 3 parts. And that gives me this step, okay, which is one step that we learned more previously, and that is divide by the coefficient. And we divide by that coefficient, that gives us a new equation, which happens to be our solution. X is equal to 1. Okay, now, we want to know, let me make sure I did not make a mistake, so I got to make sure that this is actually true. Okay, now, what I'm going to do is I'm going to check it to this equation right here. This is our original equation, and so we're going to now plug it in to see if it's actually true. Okay, so we check by plugging in. And so we're going to substitute the 1 for the x. And that gives us 3 times 1 plus 2 equals 9. And now we're just going to use the order of operations to see if this is true. Okay, 3 times 3 equals 9. 9 is equal to 9. So once I have this true statement, I can go ahead and check it off, and we can say, yes, it is true. Okay, so that means that 1 is the solution. Okay, now on our next problem, this will be number 61. We have this equation, 4 groups of x plus 3 is equal to 8. Okay, now, if we're still kind of wondering what to do, we can just sort of sketch this really quick. So I have 4 groups of x plus 3. Here's x plus 3, and I just have 4 of them. And it equals 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now we have 4 x's and 12 1's. Okay, and you can see that we can get the same thing just by doing the distributive property. That gives us 4x plus 12 is equal to 8. Okay, we're going to do our left and our right side. And then we just go through our next steps. We can take away 8. We can take away 8. Minus 8, minus 8. That's all we share. This is a 0 pair right here, so this goes away, leaving us 4x plus 4 is equal to, that is a 0. Right? We have 0 left on the other side. Now remember, my goal is to isolate that x on one side of the equation, so get rid of this guy by doing the opposite, undoing it. Make it a 0 pair. Positive 4 and negative 4 is a 0 pair. So that leaves us with 4x is equal to negative 4. Okay, and since we can't show the negative tiles here, that's where it makes it a little bit more necessary that we are able to do it without the tiles. And then our last step, let's look back here. Well, what happens when I have more than one x? You're going to divide by the coefficient, and you're going to get your equation, which is your answer, your solution. X equals negative 1. Okay, and let's go ahead and check that. Okay, let's check by plugging it in. So we go to our original equation, 4, and then this is a negative 1 plus 3, right, because that x needs to be substituted, is equal to 8. And now order of operations, do the parentheses, negative 1 plus 3 is 2, so 4 times 2 equals 8. Still not done until we have that true statement of the left side equals the right. Okay, so since this is a true statement, that means our solution is actually negative 1. All right, so important step is we are checking by plugging in. Okay, and please don't forget to divide by the coefficient when we don't have a single x. When we have more than one x, that's what we need to do. That is a necessary step. All right, so we're going to try a little more of these equations, a little bit more complicated. Okay, so our problem is 2x minus 7 equals negative 2x plus 1. Now, in this situation, this problem in the book, we have two kids that are working it out, and they get different answers. Okay, so we want to know, is this kid right, who said x is negative 1, or is this kid right, who said x is 2? So our only way to tell would be to just plug those two numbers in. So let's plug in first for negative 1. Okay, so let's do it over here. So 2x minus 7 would be 2 times negative 1 minus 7 is equal to negative 2 times negative 1 plus 1. Okay, got to make sure we remember our multiplication rules. So now this gives us negative 2 minus 7 is equal to negative 2 times negative 1 is 2 plus 1. And you always need to make sure that you are calculating correctly just in case you find different numbers, but it's actually a true statement. Okay, so this gives us negative 9 is equal to 3. And since negative 9 is not equal to 3, we know that this kid is wrong. Negative 1 is not correct, and we did all of our calculations correctly. Okay, so let's check if x is 2. So 2 times 2 minus 7 is equal to negative 2 times 2 plus 1. Okay, there's the x, which is now 1. So this gives us 4 minus 7 is equal to negative 4 plus 1. 4 minus 7 is negative 3, and negative 4 plus 1 is negative 3. So make sure that you're using your number lines or something that assures you don't make mistakes when you're doing positive and negative addition. Okay, so this checks out, and this kid is correct. X is equal to negative 2, and that's what it means. Okay, so in our next problem, we are actually going to work this one out step by step. Okay, so we have four groups of x plus 1 plus 1 plus negative x is equal to 11 plus x. All right, so let's work this one out. Now, first of all, we're not going to draw the tiles this time, but we know that since we have a number outside of parentheses with an operation inside, that we distribute. So that gives us 4x plus 4 plus 1, and let's go ahead and shorten this and call this minus x equals 11 plus x. Okay, now if you remember our steps, once we have the original expression, this is now our original expression because we distributed, we can now combine our like terms. Okay, so let's go ahead and combine all of our like terms, and we can see that we have two x terms here. We have a negative x and 4 x's. But we also have different terms, so I'm going to put a different shape, a positive 4 and a positive 1. Okay, so this should look familiar to you when we're combining our like terms previously. So add our circles, we get 3x. Add our rectangles, we get 5. Is equal to 11 plus x. So now you can see it's a lot more friendly, a lot more workable. Okay, so now getting all of our x's on one side, always concentrate on our x's first. What's my best advice? You have an x on the left and an x on the right, move the smaller one. You're always going to get a positive coefficient that way. So you have negative x, we're going to zero this out, and that puts our x's on the left. Make it a legal move. Okay, make sure that you're separating those two still. All right, now this gives us 2x plus 5 is equal to 11. Our x is still not isolated, so we need to zero out the negative 5, or the positive 5. Now that's a zero pair. And this gives us 2x is equal to 6. And then here's that situation again where we don't have one x, we have 3 x's, or we have 4 x's, but in this case we have 2 x's. So what are we going to do? We're going to divide by that coefficient. And that gives us our solution, which is x equals 3. And so now, at this point, well, this was a bunch of work. Let me make sure that I didn't make any mistakes. So let's check it. Okay, so let's put it into our original equation. We have 4 groups of 3 plus 1 plus 1 plus, this is a negative 3, is equal to 11 plus 3. Okay, so we substituted 3, and then that negative x became a negative 3, because we have to do the opposite. So now this gives us 4 times 4 plus 1 plus negative 3 is equal to 11 plus 3. And then we do multiplication first. We get 16 plus 1 minus 3 is equal to 11 plus 3. 16 plus 1, we're going left to right now, is 17 minus 3 equals 11 plus 3. 17 minus 3 is 14, is equal to 11 plus 3, which is 14. So that checks out. That means that x is equal to 3.